Hello everyone. This presentation walks through question 4 from do operation in causal networks module. We are using a joint probability table of AI suggestion, prescription, and remission outcomes. We'll answer 3 sub-questions and I'll explain what each one means and how we solve them. On this slide, we are looking at the setup for question 4. We're given the data that show how often 3 things happen together. First, which medication the clinician actually prescribed. Second, whether the patient's symptoms went into remission. And third, what the AI system recommended. The question also reminds us about a key idea called propensity score. In this context, propensity score means what a probability that clinician prescribes med A given a particular AI recommendation. To calculate that, we use conditional probability. We take the joint probability of the clinician prescribing med A and AI giving a certain recommendation and divide it by how often AI recommendation happens overall. This concept will be important for the calculations we'll do in the next part of the questions. On this slide, we are looking at the information that the question gives us. We are provided with a joint probability table that links 3 variables. X is the clinician's prescription, whether the doctor gave med A or some other medication. Y is the patient remission, whether the patient's symptoms improved, yes or no. Z is the AI system's advice, whether the AI suggested med A or suggested some other medication. Each row in this table shows a combination of those 3 variables and the probability of that combination happening. For example, the first row shows the probability that the clinician prescribed med A, the patient achieved remission, and the AI also recommended med A. That is probability 0.116. We'll use the table to calculate how often certain patterns occur and answer the rest of the questions step by step. On this slide, we introduce the idea of propensity score. Propensity is simply the probability or the chance that something happens given a particular situation. In this context, it's the chance that a clinician gives med A when already known that that was the AI's advice. So we are not looking at all patients, we are only specifically looking at the patients in the AI advice group and asking what fraction of them actually received med A. The formula is given as P of X equals med A given X. That means among all patients with certain AI advice, what fraction actually got med A. This concept helps us describe how closely clinicians follow or ignore AI's recommendations. This part of the question asks us to calculate the propensity of the clinician prescribing med A for each type of AI recommendation. In simple terms, we want to know when the AI says med A, what fraction of those patients actually got med A. When the AI says other med, what fraction of those patients still got med A. To calculate this, we use conditional probability. The probability that a clinician gives med A given a certain AI recommendation equals the probability that the clinician gives med A and the AI gave that recommendation divided by the probability that AI gave that recommendation. I know that sounds confusing, but we will go through the calculation of the question. This slide shows calculation for part A of the question. We needed to calculate the propensity of the clinician prescribing med A for each AI recommendation. From the joint table on the left, we first find how often AI recommends med A overall, which is 0.511, and how often AI recommends other med overall, which is 0.49. Next, we calculate the joint probability of med A prescribed with each of the AI recommendation. The first one is for when it advises med A, which is 0.126. And AI advice on the other med, that is 0.375. Finally, we divide each joint probability by the probability of that advice given to get the propensity score. When the AI recommendations is med A and the clinician prescribes the same med A, it is about 24.7% of the time. When AI recommends other med and the clinician still prescribes med A, it is 76.5% of the time. This shows that the clinician often do not follow AI's recommendation. Even when AI suggests another medicine, the clinician still chooses to prescribe Med A. This slide explains what inverse probability weighing or IPW means and when we use it. IPW is a method we use to correct bias in our data. It works by giving more importance or weight to some patients and less to others. By doing this, let us pretend that Med A was given randomly without having any influence by anything like AI advice. Now, why we need it? Sometimes doctors are more likely to prescribe Med A to a certain type of patients, like when the AI gives a particular recommendation. That can truly hide the effect of Med A because groups are not balanced. After applying IPW, we can see the treatment effect as if everyone had an equal chance at getting Med A, making our estimate much more reliable. Part B of this question asks us to calculate the unconfounded impact of the clinician's prescription patterns by using inverse propensity scores. Here's what it means. We know from part A that clinician does not always follow the AI's advice. Because of that, simply looking at raw remission rates might be misleading, and some groups might be overrepresented or underrepresented. To remove the bias, we use a method called inverse probability weighing. This method reweighs each case based on how likely it is to get Med A in the first place. By doing that, we create a scenario as if Med A has been randomly assigned to everyone. If Med A were prescribed randomly without bias from AI's advice or any factors, what would be the expected remission rate? In other words, we are finding the true effect of Med A on remission unconfounded by the clinician's prescription tendencies. This slide shows the calculation for the second part, where we remove the bias using inverse probability weighing. From the table, we first take the joint probabilities where Med A was prescribed and the patient went into remission grouped by each of the AI advice. For AI advice Med A, that the joint probability is 0.116, and for AI advice, other met that probability, the joint probability for that is 0.274. Then we divide each of these joint probabilities with the corresponding propensity score. When we divide AI, for AI advice med A, 0.116 is divided by 0.2466, which gives us 0.4704. Similarly, when we do the same thing with the other med, the contribution of that is about 0.3580. When we add those two contributions together, it equals 82.8%. After adjusting the confounding using inverse probability weighing, if Med A were prescribed randomly without being influenced by AI's advice, this expected remission rate would be 82.8%. This part of the question asks us to calculate the impact of AI system on remission. If we follow whatever AI recommends, what is the overall chance that a patient will go into remission? To do this, we look at each type of AI advice separately. First, we figure out the probability of remission within the advice group, that is written as P of Y equals Y given Z. Then we multiply by how often AI gives that advice, which is P of Z. Finally, we add up the products across all advice groups. In other words, the impact of AI equals probability of remission given AI advice multiplied by how often that advice is given and then summed across all advice types. This calculation would give us an overall number that shows remission rate if we strictly follow the advice AI has given us. Here's the calculation for part C, and here's how we do it. We look at each AI advice group separately and calculate two things. The probability of remission within the group that's written P of Y equals yes given Z. How often the advice happens overall, that's P of Z. For Med A, the joint probability of remission in AI advice Med A is 0.45. And you divide it by P of Z given Med A, which is 0.511, which gives us the remission probability rate of about 88.1%. Multiply that by how often AI gives the advice to take Med A, and we get 0.45. For the other med, when we go through the same process, um, we get the value of 0.3528. Finally, we add these two products to get 80.3%. So the interpretation of this value is that if we follow the AI's advice overall, we would expect about 80.3% of patients would go into remission rates. This brings us to the end of the presentation. We looked at how to calculate the propensity scores and how to use inverse probability weight to remove bias and how to measure the overall impact of AI system on patient remission. Thank you for your attention.